Hi, I'm Ms. Fung. Today we are into the second video of circular functions and we're looking at cosine and sine. So cosine will be written as cos, and it looks like this. Cosine theta is going to be written as cos theta, and sine theta is going to be written as sine theta, like so. So we're going to just use the abbreviation from now on. Here we have the unit circle again. Let's say I pick a point on the unit circle with an angle theta, then this point is going to be described as p theta. So the point with that theta. Now we notice something about this point, that the height, the y value, and the base of that triangle is x. We also notice something about this triangle, that this is a right angle triangle. And we know from right angle triangles that we can do SOHCAHTOA. And here we have the opposite to be y, the adjacent to be x, the opposite to the angle to be y, the adjacent to be x, and the hypotenuse is 1. So if we plug it into sine and cos, where opposite, hypotenuse, adjacent are the things we just mentioned, we would obtain sine theta is opposite of a hypotenuse, so y over 1, and cos theta, adjacent over 1, will be x over 1. Now this is pretty cool because, well, y over 1 is just y and x over 1 is just x. We notice that sine theta is equal to y and cos theta is equal to x. So our x value is also the same as cos theta, and our y value is also the same as sine theta. Let's practice that a little bit more so our minds get used to that. So again, x is cos, y is sine. So if we go and move around, we can see that y decreases or sine decreases as x gets bigger. If y gets really small, then x gets bigger and closer to 1 because the radius is 1. So let's have a look at a few values. At theta equals 0, right at the start there, we see that the x value is 1, therefore cos is 1, but the y value is 0, therefore sine is 0. Now if we go to pi on 2 or 90 degrees, we can see that the x value is now 0, but the y value is 1. So cos is 0 and sine is 1. Where do you think we'll go next? You probably guessed it. We're going all the way to 180 degrees or pi. So here we have our x value is -1 and our y value is 0. So cos is -1 and sine is 0. Then we travel all the way to here, 270 degrees or 3 pi on 2. And we can see that over here our x value is 0, our y value is -1. So our cos is 0 and our sine is -1. So make sure you're following along and you can guess what I'm about to say next and get used to the terminology, and that cos is x and sine is y. We can also go all the way around, so a full circle, and then land in the same spot, and we notice that again, x is 1 and y is 0 over there, so cos is 1 and sine is 0. And we notice that, hang on, if we keep going around in circle, 2 pi to 4 pi, we also end up in that spot. So it doesn't matter how many 2 pi's we end up, we'll always end up over there. So as long as it's a multiple, so n is a natural number of 2 pi, we always end up at that point. So whenever you see a multiple of 2 pi, you will always have cos is 1 and sine is 0. So we can write, we can see that the 2 pi, if we add it to any angle, it's not going to affect our answer. So if I have 2 pi plus 3 pi on 2, it's the same as 3 pi on 2 because we still end up at 3 pi on 2. The 2 pi is just doing one full circle. It doesn't affect the answer. So that one would be x is 0, y is -1, so we have cos is 0 and sine is -1. So what about when we go minus 3 pi? So minus means we're traveling clockwise from here. So we go 1, 2, 3. So if we have negative 3 pi, we end up over here where x is negative 1 and y is 0. So we have cos is negative 1 and sine is 0. And we notice that even numbers lets us end up over there and odd numbers makes us end up over here. So now that we know multiple of 2 pi's will just cancel out. So 2 pi something doesn't matter, we're just looking at this something by itself. We can use this information to solve some examples. So first of all, recall what is pi over 2, cos pi over 2? Well, that's pi. Pi over 2 means a half pi is up here. So cos is the x value, which means it is 0. Now let's try out sine 3 pi and 2. So 1.5 pi's, 1.5, we're here. And sine is the y value, which is negative 1. Now let's try to use that theory. Actually, maybe after this example. So negative 3 pi and 2, so negative 1.5. Negative means we're going clockwise. So negative 1.5 would be 1.5. We end up here, which is same as sine pi on 2. And whatever it is, sine is the y value, which is 1. Now let's try to use this theory. 5 pi. 5 pi is the same as saying multiple of 2 pi's, that's 4 pi plus pi. So it's the same as pi. So where is pi? We end up here. Let's count it and double check it though. So we know that it's going to end up there, but let's just count it and double check. 5 pi. 1, 2, 3, 4, 5. We do end up there. And the cos is your x value, which is negative 1. One more example, sine of 8 pi. Is 8 pi of multiple 2 pi's? Yes. It's 4 2 pi's. So it's a multiple of 2 pi plus 0. So 0 means we end up there. But let's count just because we're doing it for the first time and double check. 2, 4, 6, 8. Or 1, 2, 3, 4, 5, 6, 7, 8. So we end up there. And the y value over there is equal to 0. What about cos 9 pi? So that's equal to multiple 2 pi plus what? So 8 pi plus 1 pi. So it's equal to cos pi. So pi will be here. Let's just check though that we end up there. Let's count to check. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Another trick is to notice that odd pi's are here, even pi's are over there. So anyway, over here cos is your x value, which is negative 1. Thank you for watching. Maybe revise this last slide and I'll see you next time. Bye!